Memory. It's one of those many things we often take for granted. In one of my earliest memories, I was 2 years old, standing in a nursing home, watching this frail elderly woman in a hospital bed. I was told she was my grandmother, but she didn't seem to realize this. Instead, the only thing she seemed interested in was my dad. You see, when she was told he was her son, she grabbed his finger as tight as she could and she refused to let go. This was because she suffered from Alzheimer's disease, and even in that act, I could sense the devastation of a mother who had lost all those sacred memories of her child. Alzheimer's disease affects 1 out of every 9 Americans over the age of 65. That is a scary statistic, but even more frightening is that the very basis and foundation of neurodegeneration is what makes it so difficult for us to treat, because once that extensive damage to the brain cells, neurons, has occurred, we can't bring back that which has been lost. Our best hope in battling neurodegeneration is to identify what's going wrong at the molecular and cellular level to damage the neurons to begin with. Now, neurons aren't the only cells in our brain. These beautiful green images on the screen here are called microglia, and they're very important for brain function. Microglia are the immune modulators of our brain, and they respond to disease and injury with inflammatory activity. In neurodegeneration, we see dysfunctional microglia with very high levels of inflammatory activity that we know can actually be toxic to neurons. So what we don't know is which comes first, the chicken or the egg. Are dysfunctional microglia contributing to the initial stages of neurodegeneration, or are they merely responding to neurons that have already been damaged through other means? In microglia and every other cell of our body is a very important molecule called VPS35, which is necessary for transporting proteins within our cells. When something goes wrong with VPS35, all sorts of cellular functions can go awry. VPS35 has been genetically implicated in Alzheimer's and Parkinson's disease, and microglia from Alzheimer's disease patients have significantly lower levels of VPS35. So the goal of my research is to investigate how important is VPS35 for microglia function. To do this, I've employed the help of some very good friends of science, mice, and I've removed VPS35 from their microglia. So not only do these mice have more numbers of microglia than they should have, but they have dysfunctional microglia with high levels of inflammatory activity. And when I look at the surrounding brain tissue, I see changes and defects that are very similar to changes we believe occur in the early stages of neurodegeneration. This is very exciting to me because it implicates a microglia-specific molecular mechanism that might be contributing to these early stages of neurodegeneration, in which hopefully we can target diagnostically, preventatively, or therapeutically to interfere with disease progression before extensive neuronal damage occurs, in hopes that we can help more parents and grandparents hold on to those precious memories. Thank you.